Right now, you are hearing the faintest sound anyone has ever measured. You cannot hear it with your ears, but an instrument is hearing it, a steady, narrow tone, and it is arriving from a place no telescope on Earth can reach. It is coming from the space between the stars, and it is being carried to us by a machine older than the home computer, low on power and still tonight, sending. According to every model ever built to describe that region, this tone should not be there. Not like this. The machine is Voyager 1, the only object our species has ever placed in interstellar space, and the researchers listening to it face one question with two possible answers. One answer fits everything we know. The other means we have been wrong about the space between the stars. Nobody has settled which. That is what this is about. To understand why a faint tone matters, you have to understand where it comes from. Our sun does more than shine. It blows a constant wind of charged particles outward in every direction, and that wind inflates an enormous bubble. Every planet sits inside it. Every moon, every comet, every spacecraft we have launched, every living thing that has ever existed, all of it inside this one bubble of solar wind. The outer edge, where the wind finally loses to the pressure of the space beyond, has a name. The heliopause. It is the true edge of the solar system. Inside is ours, outside is something else. For a long time, we could only guess what that outside was like, and the models mostly agreed. Interstellar space, they said, is quiet, thin, cold, still. A smooth, near-empty background between one star system and the next. Then Voyager 1 crossed the heliopause and became the first machine in history to measure that region from the inside. The readings did not match the calm picture. They showed motion. They showed structure. They showed conditions that changed from one stretch of space to the next. Here is how the probe reads it. Interstellar space is not truly empty. It is filled with a thin plasma, gas so energized that its atoms have broken into charged particles. And plasma has a habit. It vibrates, and the pitch of that vibration depends on how densely the particles are packed. Measure the pitch, and you know the density. The trouble was that Voyager could only catch that pitch on rare occasions. Every so often, a violent eruption from the sun would travel all the way out to the edge of the bubble and set the interstellar plasma ringing. Voyager would catch the tone, take one reading, then hear nothing for a long time. So our knowledge of that whole region was a handful of scattered readings with long silences between them. And then something arrived in the data that no one expected. A tone that did not fade. A tone with no eruption behind it. A tone that simply stayed. And to understand what it was, you have to meet the person who found it. At Cornell University, a doctoral student named Stella Koch Ocker was working through the output of the probe's plasma instrument. The faint stream of numbers most would assume held nothing. The dramatic eruption tones were easy to spot. What she studied was the space between them. The supposedly empty stretches where the models had promised silence. They were not silent. Buried in the noise was a signal, extremely weak, extremely narrow in pitch, and unlike the eruption tones, it did not come and go. From a certain point onward, it was simply always there, a continuous faint emission produced by interstellar space itself, needing no push from the sun. In her own description, the signal was faint and monotone because it sits in such a narrow band of pitch. What she was hearing, she said, was the persistent hum of interstellar gas. Understand what that meant. For the first time in history, we had a steady, continuous reading of the density of interstellar space. Not scattered points anymore, but a running measurement, updating as the probe pushed deeper. And what it showed rewrote the calm picture. The senior scientist on the work, James Cordes, put it this way: "The interstellar medium is like a quiet, gentle rain. And when an eruption from the sun rolls through, it is like a burst of lightning in a thunderstorm, before everything settles back to the gentle rain." That gentle rain was the discovery. The background the models had called quiet was not quiet at all. Its density rose and fell at scales from the small to the enormous. The space between the stars, which we had described for a generation as smooth and empty, turned out to have structure of its own. And we had never known, because we had never had one instrument standing inside it. Every model of that region had been built from inside our own bubble, from telescopes, from mathematics reaching outward and guessing. The moment we finally placed one machine on the far side of the edge and let it listen, it told us the guess had been incomplete. But the hum did more than correct the picture. It opened an argument, because there is not one explanation for that steady tone. There are two, and they do not describe the same universe. Here is where it gets strange. Start with what the tone actually is. Its pitch tracks the vibration of the plasma, and that vibration tracks the density. So the hum is a live readout of how thick or thin the interstellar gas is at the exact spot the probe is passing through. As Voyager moves, the pitch shifts, and that shifting pitch draws a continuous line of the density of the space between the stars. And the line was not flat. It rose and fell, at scales from the small all the way up to the almost unimaginably large. The question is, what produces the tone? And this is where the researchers split. The first explanation is the calmer one. It says the hum is just the plasma vibrating on its own. The plasma is warm, its charged particles always in motion, and that motion sets the whole medium ringing at its natural pitch. If that is the answer, it is a genuine and important discovery, but it fits inside the physics we already have. The models get refined. They do not get thrown out. The second explanation should make you sit up. It says the tone might be something called quasi-thermal noise, a subtler effect tied to the fine motion of the electrons in the plasma, carrying information about the density and temperature of that gas in a different way. If that is what Voyager is hearing, then our models of interstellar space do not just need refining. They need substantial rebuilding from a low level up. Two answers. One leaves our picture of the space between the stars standing. The other says, start over. And here is the honest, frustrating truth. We do not know which is correct. There is a clue that cuts against the second option, because the tone is narrower in pitch than quasi-thermal noise usually produces. But that is not enough to close the case. To settle it, you would need a far more sensitive instrument, a much longer antenna than the one Voyager carries, built for exactly this measurement. Voyager was not built for it. It only stumbled into asking the question. Now, widen the view, because the stakes reach further than a single tone. That same bubble of solar wind does more than mark the boundary of the solar system. It also blocks a large fraction of the high-energy radiation streaming in from the rest of the galaxy, the particles thrown out by distant exploded stars, before they reach the inner planets at full strength. It is part of what has kept the space around this planet as steady as it has been for a very long time. And Voyager is telling us that the region pressing against that bubble from outside is more restless and more energetic than the models assumed. We do not yet know what that means for how the bubble holds over geological time, but that we now have to ask the question at all, from real measurements instead of guesses, is itself a shift in how we understand our place out here. There was another surprise waiting at the edge, and it points the same way. For years, the prediction was clear. When Voyager crossed the heliopause, The magnetic field around it should swing sharply, from the sun's own field inside to the very different field of the galaxy outside. Two separate environments, cleanly divided. That is not what happened. The direction of the field barely changed. Inside and outside, it pointed almost the same way. Later, its twin, Voyager 2, crossed at a completely different spot and found the same thing. Our bubble and the galaxy beyond it meet in a way the models did not predict. More blended, more connected than anyone had drawn. And the instrument telling us all of this is dying. Right now, the machine hearing the hum is one of only 2 science instruments still switched on aboard Voyager 1. Every other one has gone dark, shut down to save power. The craft draws its electricity from a generator that turns the heat of slowly decaying plutonium into current. And every year that current fades by about 4 watts. There is no way to add more. The 3 small computers aboard hold, between all of them, less memory than a single photograph on the phone in your pocket. And they were the best the world could build at the time. Recently, the team switched off the detector that had measured charged particles almost since the day the probe launched, not because it failed, but because there was no longer power to run it. Engineers are now preparing a last effort, one they have nicknamed the Big Bang, to swap a group of systems for lower power alternatives and keep the craft gathering science for as long as it can. And this is a machine that has already, once, gone completely silent and been brought back. Not long ago, Voyager 1 stopped making sense. For months it kept transmitting, but what arrived was unreadable. A stream of nonsense the engineers, after decades of reading everything this probe had sent, could not decode. The cause was a single failed memory chip, quietly given out after decades in deep space. It could not be replaced. It sat billions of miles away, and every instruction took close to a full day to arrive, and another for any answer to return. So the team rewrote the probe's software from Earth, breaking the damaged code into pieces, finding empty corners of the old memory to hold them, and stitching it back together across that delay, knowing a single wrong command could end the mission for good. One slow exchange at a time, month after month. The project manager, Suzanne Dodd, said it would be the biggest miracle to get it back, and that they had not given up. They got it back, and the hum came back with it. So this is where we stand. The tone is real. It is still arriving, and we still cannot say which universe it describes, the familiar one our models already know, or the stranger one where we have to begin again. Settling it needs more data from a probe that is going quiet, or a new mission to interstellar space. There is no such mission. It is not built. It is not funded. Even if one launched now, it would not reach that boundary for decades, which means the single live measurement humanity has ever made from inside the space between the stars may end on a question we never answered. There is one more thing worth sitting with. Very soon, Voyager 1 will become the first object our species has ever built to sit a full day of light away from home. So far that a signal moving at the fastest speed anything can move will take an entire day to reach it, and another to come back. More than 5 times farther from us than Neptune. And for all that distance, for nearly half a century of flight, it has crossed only a tiny fraction of 1% of the way to the nearest star. Bolted to its frame is a gold-plated disc. On it are greetings in dozens of human languages, the sound of rain, the sound of laughter, music gathered from across the world, and a map that marks where our star sits, drawn from the steady rhythm of distant pulsing stars. The astronomer who helped design it, Carl Sagan, described the disk as a bottle cast into the cosmic ocean. It will still be traveling long after every city that built it is gone. The signal is still coming. The hum is still there, and the question of what it means may fall silent with the machine that found it, still unanswered, still arriving, one faint tone at a time.